Uh, use probably an expert on this already, but we'll be talking about the Slurm research cluster over, and I thought they were going to be down today because of maintenance, but it turns out it only took them an hour to do maintenance, so they're up. So I want to actually go over that so that if there's any questions, we can cover it on Thursday. But we'll go ahead and try to go through some examples on how to actually run stuff on there. So I did discover something really cool recently. It's one of the reasons why I like poking around. Apparently, and this didn't exist when I started using these silly things, but it turns out there's have an option now for TrueType fonts, and if you do have TrueType, if that is available in your Xterm, it actually allows you to get very, very large. I never realized that, partly because I think when I first started working on a Unix system and X11, TrueType fonts were something that didn't exist back in the day. So this is, I wish I had learned about this. I wish I'd learned about this at the beginning of the session, and we could have been able to see things. So right now I'm logged into my laptop. Just to cover some commands. Host name tells you where you are. PWD is what directory you're in. And what I'm going to do now is I'm actually going to SSH into the research cluster, and their head node is known as rs. I have to give it my username, ion.rc.rit.edu. All right. And if you have activated your account, it should be your credentials for logging into any RIT system. So since this is something that doesn't always show up, this is the first time I'm logging into Ion from this laptop, and people get a little confused about this message here. What this message is just simply saying is that you're logging into a machine that I have never. Your machine is saying, you're logging into a machine that I have not seen before. Are you sure you want to do this? All right. So it's just a sort of a warning. It's not really an error. A lot of people get a little confused by this because they see too many letters without any strong message of what's going on here. But if you really dissect all the little pieces here, it's just simply saying to you that we're connecting to a machine that I've never seen before. And in doing so, it's asking you, are you sure you want to connect to this machine in case you really don't know, in case it's giving you a chance to back out, all right? And typically when this is the first time you log into a specific machine, a fingerprint is created. In other words, a signature associated with that machine is generated. And the reason for this signature is that so if other people are trying to create what's known as a man-in-the-middle attack, it'll know. All right, it'll know that that signature from that machine is not valid, and it'll say, "Oh, wait a minute, you're connecting to a machine with this name, but the signature that I see for it is not what I expected to have." All right, and this is what it's doing when you first log in, is that it's establishing a signature so that every time you log into this machine, it'll check that signature to make sure that it is still the same machine. Because if it's not, there may be somebody who's doing what's known as a man-in-the-middle attack, where they're spoofing this particular system and be able to essentially grab any traffic that you have. So this, it's hard for me to show this all the time because I keep forgetting that I've already logged into a machine that never shows up. But in this situation, this is the first time I'm logging to Ion from my laptop. So in the most case, you just want to say yes, right? And you'll never see this again before. So as you see, it says permanently added to your list of known hosts. And that's all it's saying, is that I know from now on, whenever you log into Ion, all right, I have a signature that is attached to it. And it took me a while to broken pipe. I don't know what that is. So, all right. Oh, it didn't connect because I probably spent too long to type in a password. Oh, I didn't type in a password. Duh. Like I said, I start rambling. Okay, so now we're on Ion. Do that host name. Just as a review, uname -a gives you a whole lot of information that most system administrators would like to know if you have typed in if you have problems with a specific machine. It gives you all the details about what kind of Linux it is, version numbers, etc. So I'm going to create a test directory. You don't have to do this, but what you want to do now is you want to copy my images directory into your home directory or other wherever directory you want to use. So to copy from the CIS systems, you would use the scp command. Okay, -r for a recursive copy, because what we're going to do is we're going to copy a directory, and that directory is in my home directory. So we have to say your username, tornado.cis.rit.edu, and then what you want to do is you want to copy syshome. Is it syshome? I don't remember now what my RVRPCI. Let's see if tilde works. Images. So SCP is a secure copy, and it allows you to copy from one workstation to another workstation. And -r means it's recursive, so it's going to connect to Tornado, and hopefully it'll resolve that tilde RVRPCI and copy the images directory to your home directory. Okay. So what you have to type in now is your CIS password. And you'll recognize that what's being copied if it's working. This didn't work.
I got permission denied.
Permission denied. All right, let me change my permissions, which is actually a good segue into how to actually change permissions properly. So let's do this. Make this big. So what I'm going to do now is I thought I changed that, but apparently I didn't. RVRPCI at tornado.cis.rit.edu. So what you have to do is you have to do a couple of things. You have to check the it's not recognized as a directory. Oh, sorry. ls -ld. That basically tells you what the protections are for your home directory. This is where a lot of people fail to change it. And what you want to do is you want to make sure that it's readable and executable for group or others. So these lines right here are an X. Okay, R means I can read it. X means I can actually go into it. I can CD into it. So the first three letters are for the user, these are for the group, and this is for other. Okay. So that means that anybody can essentially go into this top level directory. And what I needed to do is actually change the images directory, and what I'll do now is I'll do chmod group and others plus R for reading. And the capital X basically says if it's a directory, go ahead and put an X next to it. If it's a regular file, don't. Okay. And then I actually have to put a -R here, which means recursive. In other words, it'll go down this set of directories and modify it. All right. So try it now. See if you can do an SCP. Work now? Okay. Yep. So those are the basic commands for changing the permissions. Right. Group, others, Plus is add a reader execute. Minus can be removing them. Okay, and you can also set it so. Yes.
You went up to IN and then you SSH back to the tornado again?
Yes, I actually started a different session.
Can you just open up two extra windows?
Yes, you can. You can open up. It's as if you're sitting at two different terminals, so it's not a problem at all. So that's just what I did. So you should have been able to copy the images directory, and we'll just look at let's go into that images directory. And the place that you want to go to is MISC, cd MISC. And you'll notice that it's all those different files that we had in the past, okay, different directories or different files. And what we're going to do is we're actually going to first make a very small example of basically a small makefile and a script. So the idea here is how can we actually take all these files and run them through a process that we can distribute to different CPUs. And in this case, all we're doing is we're going to flip the image. So that's a very quick way of doing things. Now, what we're going to do is we're going to pretend like this process takes a long time. So we're going to put a delay in the process. Let's actually, what I typically tell people is that if you're going to start creating a batch job, it's always good to go through it by hand once. So what I will do is I'll create a directory, call it image-00. All right. And I'm going to sort of establish what I want to do. And let's copy one of the files here. So cp, I'm already inside image00. I'm going to copy house.tiff. And now this is why I tell people it's like, don't worry about, don't use the specific file name. Let's create one that you'll always remember. So what we can do here is call this input.tiff. And hopefully the reason will become obvious later. Right? So we want input.tiff. So the command that we want to do is give something like convert input.tiff. And we want to flip this and call it answer.png. And if we look at that, nothing fancy here. And that's the idea, is that we want to focus more on the mechanics of this instead of having to deal with some obscure algorithm. We want to verify that everything is working. And sure enough, it is working. So we've done that as a single command, but what we want to do is we want to put this into a makefile. All right? And the question is, well, why do you want a makefile? If you have a whole bunch of processes and it takes hours, if not days, and all of a sudden they do maintenance. Right? So that means that your jobs are going to be interrupted. If you don't use a makefile, it's kind of hard to know where to start the job again. So what we will do now is create a makefile just so you see how that works. We're going to say, in fact, I already made one. I'm going to copy it from a directory called common inputs. And we'll dissect that so you can see what is going on. Oops. Do I have common inputs? Make sure I copied the right thing. Ooh, it's not there. You guys don't have common inputs on there? Oh, you know what where it is? Yep. So what you can actually do is copy. So wherever you are right now, you can say cp tilde rvrpci, because it is actually on my on this account, and let me make sure that the directory that it's readable. Images MISC group. So let me just change the permissions for that. It's R geo plus RX. So we want to say tilde rvrpci slash images, so that's MISC, slash common inputs. Oh, has to be a -R for recursive, sorry. And another script that we want to copy is create or make directory.bash. Sorry, I got mixed up where I was when I was going through this example. So you should have a common inputs directory, and that file make directories.bash. So what's in common inputs? There's two files. One is the make file, which I said we would copy. So let's go back into the directory image 00. And we want to copy that make file. Actually, let's copy everything. So what you should have now are these 4 files: input, the answer, the make file, and that slurm.bash. And we'll talk about what that means, what that thing's actually doing. So let's look at the make file. So the make file basically says if the answer.png exists, or if it doesn't exist, it's dependent on input.tiff, and the way to create it is to give the following command. So it says convert input.tiff, flip the answer, and then here we're telling it to sleep for 300 seconds. So this is sort of a simulation that says this particular process will take about 5 minutes. Slurm.bash is really nothing more than a wrapper that basically invokes the make command. Okay. This is what actually Slurm, which is the scheduler, uses to try to take this particular case and then look for a system that has a memory of about 4K or 4 gigs of memory and run this process. If we had just typed make right now, it'll say make it's up to date. I don't need to clean this. I don't need to run this because it already exists. However, if we remove that file and type make again, it'll actually do that. Okay, so it's actually doing that now, but it's not finishing because it's sitting there waiting for 300 seconds to pass by. Right? So this is the basis of our initial directory. Right? So this directory just basically says, give me an input, process it, save the output. Very straightforward. Now the question is, how do we actually propagate this information for all these files in here, right? So you can go, you can do things by hand and say, okay, make a directory image -01, go pick out one of the TIFF files, rename it, copy it over, 02, copy it over, and so on and so forth. Well, what I've done is I've given you a script called makedirectories.bash, and we will actually go through all the pieces in there so you can understand what's actually going on here. And actually what I'll do is as we go through each line there, I will describe what each line is doing and actually type in the comments. Whoa, imagine that. So make directories.bash. And there's nothing there, that's not good. That's because I'm in image 00. Let's go back up. Okay. So this is a shell script. Starts with bin.bash. So what we're going to do first, and just to review what's going on here, is I'm going to actually use this file called caselist.txt. Where did that come from? Well, we could just simply say caselist.txt. Doesn't exist, but we can make it. We can say ls star.tiff caselist.txt. Redirect this file. Right. What does that do? It simply creates a file with all the directories .tiff on it. Right. And what we're going to do is to take that information and put it in a variable. So if you look at what we have in make directories, we're going to give this command. So this command says take all the entries in caselist.txt and put in a shell variable array. So let's actually see that in action. If we said case, what do I call it, cases, equals cat caselist.txt. We can say echo $ cases star. And we can actually go and pick out each one of them using that a numeric index into that. All right. So that explains that. The next line is to simply say, oh, tell me how many lines are actually in this file using the wc command. Right? The wc -l caselist.txt, and this will actually tell us how many lines are in the file. If we say wc -l caselist.txt, we have to pull out that number 44 out of there. All right, and we do that by the following. Right? We said pull out the number 44 and then use that as part of the sequence command. What is a sequence command? The sequence command will basically allow you to, let's actually go through that, and cases equals wc minus l case list.txt. Okay. Echo dollar and cases. And we need to pull this part out because this part is actually of no use to us for the following command, which is to say n equals the sequence starting from 1 to $n cases of 0. Oops, what did I forget? I should have done minus W. Why? Because in doing that, you pad the numbers with zeros. Because if you try to sort the first group of numbers, it'll go 1, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So it's not ordering things in the way that you would expect it in numeric form. So it's necessary to actually put the zero padding. So that's what the minus W command or option tells you to do. Okay. All right. So let's just figure out number of entries in the list. And then create a set of sequence numbers. Right. And this is one that you may not have seen before, and actually I don't use it often enough that I have to look it up occasionally, is set up a counter for your loop. Okay. Yep. Now, so far, I think everything's pretty straightforward. The next thing what we're going to do is we're going to actually start creating this. As you go through this process of creating directories, you can also create the files that will do the submission. So what we're going to do here now is we're going to start building the script that will submit the jobs. Slurm jobs. Okay. And what we're just doing is saying I'm just creating a I'm echoing to it. Okay. And now this is where a lot of the work happens. And I'm going to comment this by saying go through all the files in the list, create a directory called image-something. Okay. Create a symbolic link to common inputs. Okay. It's stalling out. It's not responding. Machine not responding. Oh, there we go. Oh, great. on Ion. No. Are you guys on Ion? Is it responding for you guys? Yes? Is it still responding? It won't let me log in now. It's not letting me log in. It might be my connection. Everybody's still logged in, right? Yeah, it's me. Yeah, it's me. I just lost the network. All right. This usually requires a restart. Ugh. Oops. Say RVR PCI. All right. So let's just go through this. I won't. So what we're doing is we're going to create a file called submit all. Oops, it's not showing. Sorry. I forgot to connect to. Come on. I'll do this too now. It's time for a new computer. Back to here. All right. So this file, this line here, basically says, we'll create a new script where we'll put all these commands. So we go through each case number. We create a directory. We go into that directory using the pushd command. And then we create what's known as symbolic links. Okay, what this is doing is saying, create a link from common inputs and put it in this current directory that I'm in. Likewise, go and look for each of those TIFF files that we have from that list and link it to input.tiff and then go out of that directory. Right? So it's pretty straightforward. And then what we're going to do is we're going to push out, we're going to generate this, this command which says go into the directory and give this command called sbatch. What sbatch does is it'll look for a script and use that to tell Slurm how to submit those jobs. Okay. And put that into that file. I think it's best to actually see this in action, so we'll do that. So there's that file, make directories.bash. Note that that's the only bash file we have here. And I'm going to invoke that by simply saying make directories. So what this did, it went through and took all those entries in caselist.txt, okay, created the directory, created each one of these directories, okay, from image 01 to image 43. And if we go into any one of those, right, it's basically what we had before. And what's interesting about this is that if we look at slurm.bash, okay, if we do more on that, right, and if we go to more on image 25, slurm.bash, they're the same, right? But then if I edit the one in image 24, and we do more image-25 slurm.bash, that change propagated. Okay. Because it's a symbolic link, it's all pointing to the same file. If you make one change in common inputs or in any of the other files, that change propagates through all the directories you've just created. So this is different than if you made copies of it. Okay. If you made a copy of that same file and you made the modification in one directory, you have to go through and recopy all those things again. By using a symbolic link, you can make that change in one directory and it propagates to the rest of them. Okay.
I didn't understand on the slurm.bash, the only statement being executed is the make statement.
Correct.
So why are you not using the word make instead of why the bash, slurm bash?
Because what it does is that the Slurm will actually look for this file,
Oh, I see.
and then take this file and distribute it to each CPU. It'll see this and it'll say, oh, what command am I going to execute? It's the make command. Okay. And yeah, it's a little quirky because it's like, well, why don't you just type make? Well, keep in mind that what we're doing is we're going to try to distribute this throughout all the different machines. So that's just the advantage of using a couple of things. One is the symbolic link. Okay, so now if I go to common inputs, right, and then if I edit any of these two files, those changes that I do on any of these will propagate to any of the files that I've just created. Right. So let's actually go ahead and submit these jobs. So before we submit the jobs, one of the commands that you want to do is sinfo. It sort of tells you what machines are available. Okay, you have to sit down and actually look at these in greater detail. But the file that we just created, star.bash, submit all.bash. Let's look at that. Right, and all it does is it goes through each directory and does an sbatch command. What the sbatch command basically does is that take this file, slurm.bash, and send it off to the scheduler. So scheduler knows that it has to go through each one of this. And you can see we're going into each directory and then coming back out, going to each directory, coming back out, going to each directory, and coming back out. All right. So the other command that you want to keep track of, or that you might want to know, is the watch command. And the watch command will, well, before we talk about the watch command, let's talk about the SQ. Right. SQ basically tells you who's on the system, but all you really care about is your stuff. Okay. And basically it's telling me that there's, the queue shows nothing that I'm running. If I say watch, quote, SQ grep RVR PCI, it'll just sit there until I submit something. So what I'll do is I'll actually submit this job. The submit okay. I have to make it executable. And I can say submit all.bash. Goes through, and now I can watch it in action. This is probably the only grep RVR PCI. As you can see, it distributes a bunch of these jobs to several machines. I don't know how many machines it is, but let's make it smaller. Maybe we'll find out. Okay. So as you can see, it submitted all of those jobs to all these different machines, and you can see the time that is elapsing. We made it go for 5 minutes, so when this hits 5 minutes, all these jobs should finish. So in the meantime, I'm just going to talk until that finishes. But a couple of things that you want to note is that, I forgot. Oh, if you were to run this sequentially, and each of these jobs is 5 minutes, so whatever 5 minutes times 43, that's how long it'll take to generate all those results on sequentially. So what you're seeing here is that we're getting a whole bunch of machines I don't even know, but actually we can find out by saying SQU grep RVR PCI, and then I do the WC minus L, and we're actually using all 44 machines, or 44 cores at once. So what you're doing is you're going to take a job that takes several hours and essentially finish it in 5 minutes. Okay. Because what you've done is you've distributed all those jobs, and it's actually finished already. It's just sitting at the sleep command and just waiting, just to simulate what would happen. So if you guys run anything that's long, this is the way to do that. If you have any DIRSIG jobs, if you guys do any DIRSIG jobs, this is the kind of things that you want to try to use. So what you should have now is a set of an example where what it's going to do is just simply flip those images, but you have the mechanism of actually submitting it into the cluster. A couple of the things that we have here, the QoS equals free is an option that basically allows you to use the cluster for free. If you have a contract with them, they actually have paid queues, which means it's always guaranteed. So if there's anybody here that's, if anybody submits it with a QoS quality of service that's paid, they have the ability to basically kill your job and continue with that. So, and that's why the makefile is sort of critical, because if somebody comes in and says, you know, I'm a paying customer, I can kick your job out of there. Your job's going to stop in the middle of your runs. So what you want is a way to be able to say, oh, how do I go about running these jobs again without having to figure out where to restart it? The makefile would sort of take care of that process, because if answer.png exists, then your job's been done. Okay, if it doesn't, then run that job. So we have about almost a minute left, and once that minute is, this whole list should clear out when it hits 5 minutes. Okay. It's typically not that clean when you're dealing with other cases.
Have you just done a tree or?
No, but I will be.
No, we can find somewhere else.
No, I should be finishing up because I have to head out. So, yes, question.
How many cores are on this list?
There are up to I didn't check, but there's like 300. They're actually targeting 1,500 in the future. It's sometimes you're lucky and get maybe a couple hundred at once. It's rare that you get all 1,500 because you run into issues of input-output. So sometimes the whole mechanism of writing data to and from the different CPUs will be the bottleneck associated with being able to, just because you've got a bunch of CPUs doesn't mean you can easily or efficiently access them. And there you go, it's just finishing up right now.
How do you know what graphics software is on?
Typically, you can use graphics software for batch jobs, probably to create graphs. Typically, I've asked them to put, I don't know if it's on the research cluster, but GDL and Octave. Okay, GDL is an open source version of IDL, and Octave is an open source version of MATLAB.
These basically take wireframes and render them?
You can. I mean, what I just showed you is just a small process. If you can figure out what you want to do, you can distribute it, and then. But as far as rendering is concerned, typically you won't use the batch system to do an interactive process. But if you want to one of the examples I'm doing is I'm actually going to run simulations of an aircraft going around an area, and what I've done is I've hacked up each of those positions and distributed as a job. So if we look at, we can actually look at all the results here. We can say animate. I can say animate delay 50 on image dash star answer.png. So as you can see, it actually flipped those things. We know it did, but just prove to yourself that that process did actually go through. We can watch each one of those. And again, the reason it's only showing part of it is that the first image was probably small in this case. Okay. So that's a quick intro into the Slurm process. I think the scripts that I have here are probably the most useful and valuable. If you can reproduce this on the Slurm cluster, you can dissect it and put whatever process you want in place of it, and you should be able to distribute those jobs. There's a whole bunch of other options that I did not go over. You can actually specify which machines to go to, what the characteristics are of the machines. The only thing that the characteristics that I made explicit here is that it's a big memory machine of about 4 gigs. Okay, you can also specify how much disk space is on a specific machine. But there are a whole bunch of options, and I think that's something that you guys can research. These are the ones in particular that I cared about. So, all right. Any questions? And I think for Thursday we'll just do a wrap up of all these things. I would highly recommend going through this on the Slurm cluster and see if you have any questions. I'm kind of glad that we actually were able to do it because they were supposed to be down today, but they finished it up so that if there's any questions, we can go over it on Thursday. And I'll just try to finish up a couple of the loose ends, particularly what I mentioned before, GDL and Octave, for those of you who are MATLAB and IDL users. These are open source versions of that, so that if you ever find yourself in a situation where you have to run those types of programs, I can show that to you and also discuss how you would use Unix to sort of tie in these mechanisms as part of a workflow. Okay? Thank you.